Hi everyone. I hope everyone can hear me and see me. Um, if you can hear me, give me a thumbs up. We're gonna get started very soon. It's good to see everyone again. All right, awesome. So today's session is one of my favorite sessions. We're gonna talk about React agents. React agent is something that I really like to talk about. It's something amazing that I've learned over time. And React agent is when you start seeing AI really come to life. So without further ado, what I'll do is that I'm going to go and share my screen and then we'll get started with today's session. All right. So welcome to day 3 of the 4-day bootcamp series. Hopefully you should be able to see my screen. Again, I'm going to wait for a couple of minutes. Yes, I think you all can see my screen. There's a bit of a delay from the lights from what I'm teaching to the live session. However, I will always wait to hear back from you all on how the stream is running. All right, so first thing, welcome back to our course. We're really excited. We have had a lot of people join in, watch the course offline, message me about it, posted one on LinkedIn. This has been a great experience. This is the first time we are running a live session series. We always usually do with a smaller group with Zoom. This is the first time that we've actually put it out there to LinkedIn so that everybody can join in from wherever they can. We have 2 links for you to share, for you to look at. Join our Discord community. The Discord community has a lot of things going on over there. We are trying to work on different. We're trying to help answer questions. I think right now we have more than 300 people in the group. So I would love for you, if you haven't joined our Discord channel, please go ahead, join our Discord channel. We'll try to answer as many questions as we can over there. Second is that there's a GitHub link to our repo. The GitHub has a lot of different things going on over there also. So a lot of things that you've seen in N8N, those things are currently available over there. So what you can do, you can check them out. You can see what how we have built them, what we have built over there, so on and so forth. So uh, again, what we are trying to do is we are going through these things. We're trying to explain them as much as we can, and as we go through them, we'll basically give you feedback on what it means, what it looks like over here, and try to share our. We want you to share your experience, and we'll share our experiences on how we are able to build. Um, if the Discord channel is not working, maybe the QR code went down, but we have pasted the link in the chat, so you can join from there also. We apologize. Sometimes the links get old or they stop working. All right, moving on. Those who don't know me are joining in today for the first time. My name is Hamza. I'm the founder and CEO of a company called Traversal.ai. We help build vertical AI agents across the industry. I was previously at Google. Before that, I was at Walmart Labs. With quite a few years of experience in machine learning. I'm an adjunct professor at UCLA, and before that, currently, I also teach at Stanford Continuing Studies, University of Minnesota, Santa Clara University, and a bunch of other places. So this has been a great session, working with you all, learning from you. I don't want to go without talking about the people who have put this event together. The 5 people who have been supporting me throughout the way in building this product and trying to this boot camp, and continue to work with us to improve our ecosystem. About us, while we work with customers, we also teach thousands of students across many organizations. You can see these are some of the organizations whom we have worked with, and these are some of the courses which I teach across the board. So the first one is Stanford Continuing Studies. Um, the second one is the UCLA course. And the third one is Maven courses, which we teach in great detail. This course is being live streamed only on YouTube. We found that LinkedIn Live was not the best way. StreamYard was also like we're streaming this from StreamYard, but YouTube is the best place. So I think the best thing would be is that as soon as we done, this is going to be live on YouTube, and you can come back and watch it. But we would love to hear from you live sessions on the idea to do a live session is that I can try to answer questions as I go through go through these sessions with you all, and add your questions. We're trying to get better at highlighting those questions so that anytime there's any question from you, we will make sure that we'll try to answer them. The whole idea is, let's make sure that you have access to as many things as possible. You have access to me to ask your questions here. I can always do a YouTube video, I can always post it. But if we are able to set up something like this where we are talking to each other, I'm trying to answer questions for you, that's where your gain is from me, for all of us. So ask your questions here. Whatever questions you have, I'll try to answer them. Of course, I can't answer every single question, but we'll try to answer as many questions as possible during the session. So I've dedicated time of where this is. I want to give a dedicated time to answering as many questions as possible. All right. We have Hassan and Amina, who is running who are the moderators. So they're following up with me, and they're sort of pasting questions for me, and trying to answer as many things as possible. All right. So we don't want to leave you without an opportunity to apply for our scholarship programs. We have what we try to do is we give away scholarships every cohort. So I run a cohort every 4 months, every 3 months. The idea is we want to make what we're teaching available for everyone. Of course, we can't make it free for everyone, but there are scholarship sessions that we want to offer. So this is our course. This is on Lenny's list. Being on the Lenny list is a big opportunity. As you can all see, this is an expensive course. I'm not going to lie. This is definitely an expensive course. However, our biggest thing is that we want to make it available to you for free. So if you are interested, if you would like to apply for a scholarship for this course, we will ask you to do a few things for us. The minimum we ask you is make a post about this course, so that we can make sure that we get more and more people and they can learn about what we are doing. If you scan this link, hopefully this link will work. You will be able to send us a Google form where we can get your email, get your information, so that we can send you information about the course. We can send you the deck, we can send you the code. Some of the code is available on GitHub. However, apart from the code over here, there's other code that I'm showing, for the React agent code that you will see today. There was code from keyword search previously. So what I would ask you all to do is scan this QR code, fill up the form, send it our way, so that we can send. Because the one thing that I don't want to do is I want to not re-spam everyone with everything. So if you want to send, if this is not working, and I really apologize if the links are off. I don't know why the links are not working, but we'll basically make sure that we will make sure that we will take care of that, sort of making sure that you are able to use this. Some people are saying that there's an invalid dynamic link. Some people are saying the QR code works. If anything at all, we'll keep pasting the links over here. We will keep pasting the links over here for you all, so that you guys can use it. I think what's happened is, Hassan and Amna, one of the forms that you have pasted, the link of the form, I think that is incorrect. So Hassan, if you can repost the link to the form There's an error coming over there on that. I think there is, yes. So the correct link for the form is here. I think what happened is that when it got pasted with a please in the link. So that is causing challenge. So this should be the link. And Hassan has already pasted that. Everyone has pasted that. So you should be able to use that. All right, awesome. So scholarship is optional. There's an option for scholarship to continue, learning from us, to join our live sessions, which are much more deeper. We cover a lot more topics. We would love for you to join. If you can pay for it, that's great. If you can't pay for it, apply for the scholarship so that we can make sure that we keep you upfront. So recap of day one. In the first day, what we discussed about is a lot of what agents are. We discussed how do we move from agent or from chat to workflow. We talked about automation. So first class, we talked about n8n, how it comes to life, what are the different components of n8n and how does it work. In the second class, we talked about keyword search. So we started with keyword search, then we went to semantic search, and then we discussed agentic routers within our search ecosystem. So and building into enterprise RAG. So that was the second part. Today's session, we're going to talk about ReAct, which is reason and act. And then tomorrow's class, we'll talk about agents A2A, which is agents collaboration. I really want to highlight that search is an important. Some agents do not need search, but a lot of agents that we work in today's world needs some kind of search. And having a good ecosystem for search is very, 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 very important in how you build and design it. You basically you go from keyword search to semantic search. From semantic search, you go to enterprise RAG. The reason I'm sort of mentioning these things, or I'm trying to cover them in, recapping them, is because sometimes we don't tend to follow these pattern, and we basically say, okay, you know what, I'm going to use a framework, I'm going to build my chat, or build my agent. But remember, when you have better memory and a better search engine in your agent, you definitely are adding a lot of value. And what we will do is we want to make sure that you learn these things in detail, because they play a major role in what you're building in your agent. I do want to highlight, if you fill up this form, we can send you also the code access, the coding notebooks which we have worked on. And what you can do is you can follow through. So use this QR code, get to the form, fill up the form. We'll send you the decks, all the decks that we have presented. We'll send you the code, and we'll also consider you for the scholarship. All right. Okay. And again, if you have more questions, we'll try to answer them in the session here. In today's session, what we'll talk about is React agents, how React is different from automation agents. We'll talk about React in different, a little bit of introduction. Crew AI is something that I think we're going to cover tomorrow, because Crew AI uses agent to agent, or the multiple tools and agents put together. So we'll focus on Crew AI tomorrow. And there's a library that I want to introduce you to, which is called Agent Pro. We built that library so that you can understand easily how React agent works. It is no way conclusively the best a React library, or it's not very extensive either. The idea is that if you want to understand how to build something from scratch in React agent, and what's the major differentiation from n8n, this should serve a purpose for that. All right, so we know that agents are everywhere. We've talked about agents. In the first class, we talked a lot about agents. And what I want to do is I want to get into the agentic architecture that we covered in the first class, just a recap on that. We first start with the agentic architecture, the first one, which is basically a simple LLM behind the scenes, such as, you ChatGPT or something like that. Although ChatGPT has a lot of different, building blocks of it now. However, simply put, if you're using something such only just ChatGPT right now, ChatGPT basically is an LLM powered ecosystem with a bunch of tools. The second part was N10 ecosystem, which we read. You could see that we were able to build Lisa, which has internet search capability. If you go to our GitHub, you will be able to see our GitHub with our GitHub has full of examples of how you can build more complex agents. However, they were all automation agents. And what this is, I mean, I always talk about taking a screenshot of something important. This is the important part where you take a screenshot of what we're trying to teach. Agentic architectures, there are many agentic architectures. You use automation agent, or this is the automation architecture that we have over here, which is using N10. Here, how do you qualify for automation agents? When you can map the entire process as a flowchart. Here, what you have built is you have an entire process, which, as a flowchart with clear decision points. What that means is you are basically making sure you have an idea of what your workflow will look like, and you don't want your workflow to change at any point. You want to make sure that your workflow follows a certain pattern, it follows a certain path, and you use AI as you would use ChatGPT today. It sort of just follows a basic plan. It does not break from that. It does not break from that workflow. It just stays at that workflow and sort of trying to figure out that this is how we're going to answer a question, and that is a workflow that you always want to stick to. So let's just say this is N10 over here. What we want to do is we want to receive a chat. We have an AI agent in the middle. We have OpenAI here, simple memory, and then we want to use two tools, which is internet search and maybe a ReAct tool. This is a workflow that we have designed ourselves, and we want to focus on this one. Or there is another version, which is the SEO blog, which we also have, and I showed you in the first class. This one is more complicated, but still you want a certain flow of actions. You don't want to disrupt your flow. Here, the flow stays the same. No matter what happens, you will start from here, you'll go to these steps, and then it will go to step 1, step 2, step 3. This workflow is built by a person named Sohail Jafri, very, very smart person. We picked it, we've credited him. There are links for him. If you want to follow what he has built, you can go to these links. This is also available on our GitHub, so you can follow this. So if you want to see where these N10 examples are, you can go to our GitHub. The GitHub has all links to these. If they don't, we'll make sure that they're available within the day. Right. So these are available for you all to check out. But basically, what's happening behind the scene is this tool basically creates a SEO based article for us. It goes through multiple steps. It follows and sort of builds something at the end of the day. However, if you see, there is a pattern it has to follow. It is not excuse me. It is not supposed to stray from what we have asked to do. This is the major differentiation factor when we talk about N10 or automation agents. Even though they look complicated, there is no dynamic roadmap. Every roadmap that you have identified over here will be followed through that. That is the major differentiation factor when we talk about automation agents, which is sort of the level 2. It needs to happen within seconds to minutes. The value is in automating a known process, not discovering new approaches. All right. So this is the general theme behind when we talk about agents. When we look into deterministic part of our ecosystem. Within these tools, there is something called error handling also. So you can build evaluations, which you can learn about You can basically check on is it working how we would like it to work. In executions, you can look at every single execution that has been run before. This is a new one, so we don't have executions here, but you can actually see executions happening behind the scenes. So if I show you an example, there is a Airbnb tool that we have here. The Airbnb tool follows the exact path that we have given. We have a bunch of executions over here that you can see that have taken place. It has extremely good logging, and within each node, you can identify how to handle different errors, how to handle, when something happens, what to do, how to proceed. All of those things are there, and it is logged. So having the capability to log something is really, really good in this automation agent. If you are interested in learning or using this, the Airbnb tool, if you've not seen this before, you can use it. You can try it out over here. We'll share it in the link so that you guys uh, can follow through that. All right. So coming back to the second part. The second part is what we're going to talk about today. We're going to talk about thinking and reasoning. The thinking and reasoning part is when you basically do not have a plan. You just need to show a result. However, you do not have a plan on how you're going to get there. This is usually needed when your flowchart has 13 plus nodes and you're adding new branches, continuously. You have unpredictable user paths. I mean, user can ask a lot of questions. You have many tools which needs to be selected, which API to call and how do you want to call it. And you need a multi-step reasoning, which is breaking down each step of the way to generate an answer. Right. So the idea behind the scenes is that there's a lot of unknown, and you have very complicated process workflows that are needed to generate this output. So this is where we start thinking about reason and acting agents, which basically play a huge role in helping us trying to build out something much better, much smarter, so that we start to see the added advantage of running this behind the scenes. It is built such that you can sort of evaluate it still. However, you give your LLM the first time. This is the first time that you're giving your LLM the capability to actually be able to run workflow on its own. Previously, whenever we would run our agent behind the scenes, so here in Airbnb agent, you're pretty much running it how you would run a prompt in ChatGPT. All you've done is that you've connected multiple blocks. You've connected multiple blocks here, but you're still using ChatGPT as you would use ChatGPT in the first place, right? However, when we talk about reasoning agents, we don't have a workflow. We have not defined a workflow. All we have done is that we have defined how to what tools are available. We've only defined which tools are available, and I'll skip a couple of these slides to get to the part. This is what a React agent workflow looks like. Here, what we've done a very smart thing. We have given a bunch of tools to our LLM agent over here. Let's call it the React agent. The React agent, basically what it does behind the scenes is, and I'm going to make sure I show the screen. So if you guys can see my screen, this is what the React agent looks like. A React agent does not have a dedicated workflow on how to come up with a series of actions for answers. However, it has a workflow that follows a different trajectory It follows a different trajectory over here, which basically means is when you get a user question, the LLM thinks on how it will try to answer your question. It will try to answer your question by thinking on its own on how can I answer this. So previously, we did not give the LLM capability to think on the path to take. This is very important if you think about it. Um, if you think about it, it is not focusing on coming up with or a defined pathway. When you get a user question, you go to the LLM. The LLM will think, okay, based on this, based on whatever the users ask, I have to come up with a series of actions. So the user will take a series of actions, or the LLM will take a series of actions by knowing the various tools that we have exposed to it. So it knows that I have access to a variety of tools. I'm going to use the variety of tools which are available to me to build something over here. And once every tool returns a response to me, each tool returns a response to me, my job is to make sure that it is done correctly. Once it's done correctly, it will pause, it will observe, it will pause, it will say, have I found the answer to every single thing that the user is asking? And once we have received the entire answer and it's satisfied, then only it will try to give you the final answer. So if there is error in this, it will be propagated or it will basically be canceled out. So there are two things that happen. If there's an error in the middle, we basically error out. It says it was unsuccessful, it was not able to run. Or what it does is that it passes on the error onto the next parts. For example, it will hallucinate. This is what happens when you are working with automation agents. However, on the other hand, when you're working with React agent, the React agent sort of goes back and forth, trying to think about how to generate a response for you. And then it sort of goes back and forth until it figures out, I think I am very comfortable in what I have generated for you. So what I want to do is I'll show you a very simple example. So we built this tool called Agent Pro. Agent Pro is one of our libraries that we have designed ourselves. The reason we designed this is because it is a very good explanation for you, or something that you can use to understand how React agents work. And before I go into showing you how it works, I'll show you one part of the code which sort of exemplifies on how this is different from other tools. So here, I'm going to zoom in a little bit. To the React class, we introduce this particular prompt. This particular prompt plays a major role in how you build observability and thinking capability within the LLM output. And this is what has been the cornerstone of how you see Lovable come to play, or Manus AI, or many other fancy tools which are out there which have reasoning capability. Having reasoning capability, so it is able to generate an output based on that. So first thing is you say, hey, you have access to these tools. And that's where you can actually go and see what kind of tools we have available. So for instance, there's a tool which we have built called Aries. This is internet search. And here you can see, I'm going to hide this. You have to provide a description of what the tools will do. So use Aries API to search live and detailed information from the internet and return a clean summary and related, I think, your links. Yes. So this is how we have defined the tool. This is a tool class that we have defined. And within the tool class, we are defining what it will do, what it is supposed to do when we load that class. So we have the tools defined. And then what we do is that within the React class, we introduce the tools, their description, and the task the React agent is supposed to follow. So here, the agent is required. Think about what actions is required, which is called thought. Take an appropriate action, which we call action, and repeat thought action as needed until you find the final answer. So here, think of a for loop going. Think of this loop. We have a thought, we have an action, we have an observation, and it sort of goes in the loop, not forever. We can stop the loop at 10 or 15 iterations. But what we do is it is able to help you build and generate an output for you here, which sort of goes in loop until it decides that it has the right answer. So just sharing this over here. This is the GitHub link to Agent Pro. You can directly follow on what I'm teaching over here. So you can click on this link. You can come exactly to the page I am on right now. So here, we identify the task, the thought, the action, and the final answer. And then we basically provide the steps it needs to follow. When action is needed, this is how you want to do the output, the action type, and the input. And then when you're confident in the final response, now I know the answer that will give me that will be given in final answer. Provide a complete, well-structured response that directly addresses the original question. So think of this as that we have activated reasoning in an LLM, but through our own prompting. We are not letting the LLM reason on its own. You probably have seen that you can turn on reasoning in your LLMs, in Claude, in OpenAI. We've actually activated reasoning, but through our own steps. And we have to give simple but stupid information like if stuck, reflect and retry, but never hallucinate. This is something that we have to try behind the scenes ourselves to build that. And one immediate question that comes up out of this is, how do you know this is working? How do you know that this particular output that you are seeing is actually correct? That is where, my friends, evals take a major route. Eval is what sort of plays a major role in generating a response for you. So this is a write-up that we have created. This is an article that we have written. It's literally explaining every eval that you can run based on the kind of agent that you're working with. So if you're running an agent, if you're running an eval on your agent, it basically you can build an entire eval over here, and it explains what kind of benchmark data sets you can use, how you can build it. So what I'll do is I'll also share this link. Just want to make sure this link works. Right. So this is the link to our eval. This is the link for eval that you can work behind the scenes. So and you can sort of follow through on what we've done in eval. So why do we want to do this? Why the hell do I want to go from my fancy n8n, from my easy no code n8n, to something which looks so much code to look into? This is because when you work with agents, when you work with reasoning agents, you have to give more information, and you have to give like many instructions. So this is you going from getting a frozen pizza from the store, cooking it, just baking it in the oven. Now what you're doing is you're actually making the pizza from scratch. This allows you much more control. And that is the one important thing that I want to mention over here. When we are working with simple, just ChatGPT or n8n, you have more deterministic workflow and predefined automation. However, when you start moving to the when you start moving to the right-hand side, when you want to have higher autonomy and higher self-reflection and the ability to do a better job, sort of move to the right. You move to the right. So sort of explain, or let the LLM handle, or the agent become much beyond productivity. So if you guys remember, I talked about productivity in the first class. I talked about how level 1 agents or level 2 agents automation is focused on productivity. Level 3 and level 4 are focused on introducing more complexity. We'll talk about level 4 in tomorrow's class in detail. I don't want to confuse you all right now, but think about React agents or reasoning agent taking control of what needs to be done versus you telling them exactly what to do. And in the scheme of building these tools, you basically give them more control. They're more complex, and they have higher autonomy and self-reflection in how they're building a tool. So, and I'll cover that one more slide over there in the back there. But essentially, when you want a higher level of control, when you want to build a product which has many moving pieces that you don't want to control, but you want the LLM to sort of understand and reason with it, and it gets out of control also. I'm going to be the first one to say that React agents can get out of control. They can run forever if you do not tinker them correctly. But if you build these tools properly, if you build these tools in a way that they're supposed to be built, and they play a major, they're supposed to follow through a process, they start delivering great value to you. And that's what we want to push you all to imagine. React agents come into play when you do not have a defined workflow, when it is difficult for you to control every tool and make a workflow. Here you bring in a React agent that sort of takes the steering wheel on its own and starts driving the process. So I want to show you a working example, and I want you guys to start adding your questions, because what we'll do is in the next 10 minutes I'm going to pause and I'm going to try to answer as many questions as possible. So I like to show you I would like to show you a working prototype, and we will basically go deeper into how to implement this. So this example is something what is of Agent Pro that that I showed you in the GitHub. This agent has, for instance, two different tools available, 2 or 3 different tools. The first tool it has internet search. The second tool it has the capability to find information from a RAG document. So the RAG document that we have is AWS documentation. And the third thing, it has a tool which is slide generation. It can generate slides for you. Not very good slides, but it can generate slides. So for instance, I'm going to try to, live demos are always notorious for going wrong, but I'm going to try it anyway. And I'm going to write a question. So for instance, my first question is, can you find me info about S3 bucket? Then I would like to learn about AWS product called Bedrock. And then I want to know about the latest LLMs released in December 2025. Now, I don't know how it will run. This is the biggest challenge with these tools, is that they can be erratic. Sometimes they work really well, sometimes they don't work well. However, let's try to find out what we get an answer at the end of the day, right? And while you're thinking I can do all of this in n8n, I will try to show you how it is able to reason really well and go beyond what n8n can do for us. So right now it's processing all the different requests that have been given, and it will generate an answer for you. So give it a minute. takes a minute to run. And when it's run, we will be able to see. Okay, so this is where the answer comes. So when I said, can you find me info about S3 bucket? Then I would like to learn about AWS product called Bedrock. And then I want to know about the latest LLMs released in 2025. Remember, we are using two different tools here. We have we have not defined, I want you to use RAG or internet search. I've just asked a question. Here, to provide detailed information about an S3 bucket, I would search the AWS documentation using Traversal Pro. The Traversal Pro is a RAG tool that we have built. I'll start with that. So it figured out that I will try to process information over there myself. So it sort of asks you a question. It will basically say, explain S3 bucket. And the S3 bucket sort of, the Traversal Pro agent returns the answer and says, I have retrieved detailed information about Amazon S3 bucket. Next, I will search for information about AWS product called Bedrock. Now, if you see, it said AWS Bedrock, but it received an answer also. It received an answer. However, it said the search did not return specific information about AWS product called Bedrock. I should perform a broader internet search using Aries Internet Search to find more recent and relevant information about Bedrock. And then what it did is that it searched the internet. So you see, this is an insane form of action that has happened. It evaluated, it got a response in the first place. It got a response. However, it determined, the agent determined that I do not have the right answer. The answer that I'm looking at is not the correct answer. So it sort of evaluated. Of course, if the RAG had returned something which was relevant, and even though the RAG was untrue, it would have followed on to give you the answer. But here it said, I do not have the answer that you're looking for. So what I'll do is that I will use another internet search tool. So it rewrote the query and generated a response, right? And this is an entire answer for you. Now, then it says, I have gathered comprehensive information about AWS Bedrock. Now I will search for the latest LLM released in December using Aries Internet Search. So it used Internet Search and it found out, hey, these are the latest LLMs that have been released in December 2025, right? And it gives you all the links that are related to that. So remember, this is not hallucination, because every time it has generated a response, there is grounding associated with it. So you see, even here, there's an original file name that it has used to generate an answer. And once all the answers are generated for you, once it sort of I've gathered detailed information regarding AWS 3 bucket, AWS Bedrock, and latest LLMs released in December 25. Now I'll compile all this information into a comprehensive response. And this is where your response comes in. It basically said, this is the S3 bucket, this is the AWS Bedrock, this is the latest LLM information that is available out there. All of this has been built out. All of this has been built out for you so that you can sort of see the capability of ReAct. If you were to use the same principles in n8n, you will see it fall apart. You will see it will sort of fall apart. It will sort of fail for you as you're trying to build it. But over here, what it did is that what it does is that it sort of uses the capability of the tools that it's given, of the request we have made that you have to build this correctly. You have to evaluate what has been done for you. And once it has evaluated all of these things, it sort of generates an output for you at the end of the day, which looks like this and sort of, falls through in line. All right. So I have sort of covered a bunch of stuff. We went from n8n, simple automation of n8n, in building out a tool. Now, I'm going to show you something more interesting, and then I'm going to take some questions. Let's just say, can you please make a deck explaining all the concepts? And we run the agent again. So we have asked the prior questions. We have asked the previous questions again. It's going to run the same protocol or a different protocol depending on what it remembers. However, it is going to build. Now we have added one more request at the end of the day, and that's where you can see that it's sort of coming to life further. That is sort of building an output for you. That you can see that, okay, I now have to run another additional steps, to generate a response for you. So here it went to Bedrock. Sorry, it looked for Bedrock and started with S3 bucket. It got the answer to S3 bucket. It then used AWS Bedrock. It did not find the answer, so it went to Traversal Pro again, to Aries Internet Search. Then it went to Internet Search again for latest LLMs. And then, now that it had all the information, it used the PowerPoint presentation tool to put that all together. And here, your PowerPoint presentation, I don't remember the name of the presentation, but the AWS LLM overview. So this one is now available. And I'll share my screen of what the output is in a minute. But you see, it followed through the steps. And that's what we evaluate also. We evaluate LLM's capability on how they work behind the scenes through this purpose. So I'm going to figure out how to share my screen on this one. So let's upload the file that it generated. Okay, so this is the file opening for you all. So AWS and latest LLM overviews. So it's a very simple slide deck. It's nothing fancy. But imagine if you can add some time to it, if you can design a tool which builds fancier decks, you are already ahead of the curve in what's being built out there. You can start building your own version of Perplexity. You can start building your version of Manus for your organization, because it's all about the tools which are being available, which are made available to you. The ReAct is calling all those tools, and the ReAct is building everything for you in this space. And the tool that I have mentioned over here is a deck creation tool, as I explained before. It's already built into this. So if you go through the tools that we have created, you can see that there's a slide generation tool that is added over here. So when you use a tool like Perplexity, again, I keep saying Perplexity or ChatGPT because these are the most popular ones that you've seen. To be honest, this is how it's built. You have a predefined code that is created for you with how to follow the process. All it does is that you tell the LLM, you prompt the LLM to, this is how I would like you to send me the request. This is the kind of input format that I'm expecting from you. And then your slide is generated. So remember, the tools are the all-powerful thing. Your tools play a major role in what you're developing. I want you to remember this. The LLM plays a major role in routing your request. LLM plays a major role in routing your request. However, when you look at these tools, you can understand that this is the ReAct agent play that is. Now, is this the only ReAct agent that exists? No. There are many frameworks that exist out there. You have LangChain, you have LangGraph, you have LangFlow, I think LangSmith, I don't know, too many Langs. Llama Index have them. What I want you to understand is, okay, I'm going to give you a task. Spend 20 minutes on this GitHub and spend 20 minutes over there on their GitHub, you won't understand what's happening behind the scenes over there. The reason we have built this is that LangChain and LangSmith, they're so abstracted, and they've written so much code that's very difficult to sort of recreate them for yourself. The beauty of this tool that we have built is, I'm in no way it's exhaustive, but what it does is that it gives you the capability to understand how we build something. And when you build something, when you're able to build something, you can change it, develop it to what your needs are. My interest does not lie in you using this tool that I've built. My interest lies in your ability as a developer to use these tools, tinker them on your own, and build something better out of it. That's sort of my takeaway, or that's sort of the push and the desire that I have. Um, um, uh, if if you can figure that part out, how these things are built, you can build them better, you can build them smarter, you can add more value to it, right? So i've been I get asked this question a lot. Why don't you use Crew AI? Why don't you use this? I would love to use them, and I use them, but there's a huge dependency on LangChain. And unfortunately, what LangChain does is that they change their architecture every 3 4 months without backward compatibility in most cases. What does that mean? That just means is that we struggle with putting things into production, or when things are in production, they fail a lot of times. So I really want to get a poll over here from people. How many have used LangChain in the past? And you have seen that LangChain sort of just doesn't follow through, or after 3 4 months, it sort of fails to build something over there. That's something that we have seen as a part of the process. That you see that it sort of just tends to fail, tends to error out. And a lot of companies that I'm working with, the first thing they say is, we don't want to use LangChain or Llama Index or any of those, because they just don't, they're good for demo, they're great demo tools, but when it comes to production, we need to be able to see what's happening inside of the hood. And unfortunately, they have such a complex piece of code that it's difficult to follow along in what's being built. All right, so I'm going to stop here, and I want to try to answer questions. So Hassan, if you're there, I'm going to add you to the stage, and if you can help me answer questions, or highlight the questions that people have asked, that I can help. All right, Hassan, can you hear me?
Okay, Hamza. So we can you hear me?
Yeah, I can. Go ahead.
Yeah. Okay. So the first question that we have is, I'm a product manager. How can I take help of AI tools to generate this code?
All right. So there are different things as a product manager, you want to have an understanding. Like, first is N10 is very easy. It's a product manager tool. As a product manager, you can use N10 anytime you want to build a no code tool. You don't have to follow a lot of Python code to build that. However, when you've crossed a certain threshold, and you know that your N10 requires your requirements have gone further, and you need to use a tool like a React tool. When you are in this area, I would suggest is that start with Langflow. I'm saying start with Langflow, start with Langsmith. They will help you get started. And as you get deeper in these tools, as you improve your capability in these tools, you will start to learn. The biggest problem that we have right now is we all want to learn very fast without the building blocks. Building blocks is learn N10, start with LangChain, Langflow, and see where they start to fail. And that's where you start to sort of learn Python and build through that. There is no shortcut to it. I hate to be the one to say these things. There's no shortcut in learning. You have to slowly learn. but start with doing end ends so that you can get a good handle on those things. All right, Hassan's second question.
Yeah. Yeah. So the second question is, in the case of a production agent, fallbacks and making sure that a good result comes out, how can we ensure it?
So this is where having good evaluation tools play a major role. If you have never worked on evals, you have to start thinking about evaluation. Evaluation is a very important concept. I have shared the link to one of my Substack posts. There's an entire course on evals. We are in talks of writing a book this year on evals also. So eval is the most important. So if anyone who's been a data scientist here, you won't build a data science model without knowing the accuracy of your models. I mean, we are building agents day in day out, but we actually don't evaluate them, which is so weird. You're like, hey, I built something. Look at this. It's so cool. Did it actually work? Did it actually answer your question? Did it actually do the job it's supposed to do? Those things are very important to consider, and building an eval, having the conversation about eval is important. Once you have more and more of those conversations, you should be able to build these tools as you go forward. Hassan, next question.
Okay. So the next question is, did you instrument evals in the Airbnb search tool? If so, how?
I have not added evals in Airbnb. However, what we are working on evals for Airbnb is to actually evaluate if the user asked a question, did we provide them answers for the same city that they were asking for? That's the first one. The second one is, were we able to showcase the right dates? Number three was, did we provide them links to places that were actually available at that time? And number four was, did we provide them a matching criteria based on what they wanted? So we try to store these four different information sets when a user asks a question. Based on the question, we then sort of evaluate on these four things that how good the agent would work. Because agent is not only dependent on one output, there are many outputs that are created by an agent, and it is our job to evaluate each one of these processes to making sure that they're done correctly.
Okay, thank you, Hamza. The next question is, could we define this all in a system prompt rather than through code files? Can the React agent be done through RAG?
So React and RAG are two different things. React is a framework on how you're trying to answer a question. You use RAG is a tool, React is a framework. All right. So React is a framework that says, if a user asks these questions, I want you to follow these steps. In RAG, what we do is that when a user asks these questions, this is how I want you to fetch the answer. So agentic RAG does exist. And this is the funny thing, you can add React agents within a RAG tool to retrieve good answers for you, which we showed you in the last class. Here, the differentiation is the React is an orchestration on how to receive an answer. I hope that answers the question.
Thank you, Hamza. Okay, so the next question is, can LangChain, LangGraph provide level 4 higher autonomy?
Yeah, of course it can. Of course it can. It can. I these tools are great tools if you don't want to know how they're built, or if you want to do demo purposes. Yeah, companies are using them in production too, but more and more companies that I talk to are struggling. Like, listen, everybody wants something to work, right? Like, if you're paying for something or if you're using something, you want that thing to work at the end of the day. The If it's failing you, if it's not able to generate how you want to see the answers, then you have to switch to something. And what my suggestion is, use these tools to understand the art of possibility. Don't use these tools to build something from day one. Use these tools to understand what is possible. And once you understand what's possible, then you're going to get really, really good in building. Like, this is not a 1 day journey, this is not a 2 day journey, this is a 6 months, 7 months journey in how you're going on building these tools. All right, I'll take a couple of more questions and then I'll go back to the teaching.
Yeah. So the next question is, uh, uh, okay, so this is the question. I'm trying to understand how agents are built. Is React the only framework, or are there other more specific perhaps to defining agents, or React is currently the only way to think about it?
There is no only in agent world. I just want to say this. There are many, 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 many workflows that are, so you see, the problem is we don't have a true definition of agent. Automation agent is also agent. Cursor is also an agent. Lovable is also an agent. React agent is also an agent. Everything is also an agent. So what I'm trying to show you is one of the frameworks that is available. There are other frameworks like Repo. I think there are others also. I don't remember, but React has turned out to be the most popular version, or the most popular framework that is out there, that is able to serve purpose of what we are trying to get out of the agent as a reactive part. So it is surfaced to be one of the top performer. It is no way the only one. And sometimes people are like, we could have done it, we don't want it to be, we don't want something which is top performer, or it's my use case is not React, my use case is Revo or something else. That's absolutely fine. What I'm trying to say is, it's a tool, use it as a tool. And I think maybe tomorrow some other tool will come up, so we'll adapt on it. But it is serving the purpose of what we want to do. That's why it's a useful tool right now.
Thank
All right.
you.
Yep.
Okay, so let's move to the next question. I think we can take a couple of questions, right?
Yeah.
Yeah. So can you share some best practices when it comes to conceptualizing React agents?
When it comes to conceptualizing what?
React, React
React.
agents.
Okay. So yes, I think that's a very good question, and I want to share my screen. Hassan, if you can help me share my screen again. Basically, one of the things that I want to identify over here for you all is this part. This is the most important thing that you guys should be looking into. Basically, what this explains you is the problem of building agents today. If you have too many steps, your agent will basically, it will falter, it will fail many, many times. So the problem is, when you have an agent, that exists out here, you need to make it into a verticalized agent, which is doing one thing or two things or three things at best. You can't have an agent, or you can't have 25 different tools that are running within one agent. It is the recipe for disaster. So your focus should be to building agents with 5 tools, 6 tools. And if you want to create further, you can build agent to agent. So there are 2 agents that are working together, the 3 agents which are working together. But if you build one agent with 30 tools, you're going to fail. Like, the thing will sort of be more error prone. So vertical agent is the concept that I would suggest you all follow. Vertical agent basically helps you build ecosystems which is verticalized in trying to answer one question, rather than trying to solve every single problem that is out there. Best practices: keep 5 tools, 6 tools at best. Do not overload your LLM with 30 or 40 different tools. All right, last question here, and then we'll go back to the teaching part.
Okay, so this is bit of a generic question. Can you guide about vibe coding? What is the future of vibe coding? Should it be adopted or not?
So I think vibe coding is a great tool or great approach when you know what you're doing. If you're building something and you don't know, like you have no idea how it's entirely built, that's where the problem is. So, for instance, if I don't want, what I tell people is don't vibe code an entire product without knowing what that product, how that product is built. But if you know the functions, the specific function, the specific code that you want to build, then you should do vibe coding. You should use cursor and tools like that, which play a major role. The problem with vibe coding is you end up getting yourself stuck into something which you can't fix. And we've seen that example come to life many times, where you go beyond, you actually tell it to build an entire repository versus individual functions. So if you want to build individual functions in which you understand what has been written for you, then you should vibe code that function. Don't vibe code an entire repository for yourself. If you're trying to create an entire repository, that is a recipe for failure for you right there. And that's where you're going to see a lot more failures. Like even in Lovable, when we do live vibe coding and we built a front end, the problem is sometimes it just errors out and you sort of have to throw the whole thing out and start from scratch again. And you don't know what was the vulnerability, what were the challenges, what were the issues. In fact, there is so many practices that are out there that have been followed in these tools that is not really best practice. The way these tools and these websites are being built in vibe coding. So use vibe coding for function building, to write one function, two functions, and then do an iterative process rather than having the entire ecosystem built for you in the first place. All right, I hope that answers your question. All right. Thank you, Hassan. So what I'll do is now I want to go a little bit further into React agents. I think we have very little stuff to cover anymore anyway. But React agents are so good because of one important concept within them, is that they have some kind of memory. This is the last topic I'll cover today, and then we'll talk about memory in tomorrow's session too. But memory is what enables these React agents to become so much better. So for instance, memory basically refers to, there are two kinds of memories that we work with. There's a long-term memory and there's a short-term memory. Short-term memory refers to the working memory. So when you're going from one step to the other step, there is generation of context generating, prompts are generated, evaluation are created. There are a lot of different outputs that are generated. Being able to stitch them together and keep them running is what short-term memory is responsible for. So short-term memory plays a huge role in running the agent at the time of processing from one step to other, from A to B to C to D to E. So the end-to-end process, one run of an agent, is what short-term memory plays a huge role in. And on the other hand, you have long-term memory. Long-term memory is to help you remember previous things. So for instance, if somebody is asking the same question over and over again, why should I need to run the entire tool usage all over again? Why can't I use the memory of what it ran that is stored, pull back that memory, and just give the answer? So a concept of this is caching. Caching basically refers to the fact that you basically are storing everything that was run before. I mean, that's one kind of memory, but imagine you're building a customer support agent. The customer support, they would like to provide you. Why should the person have to provide you with their number or their order ID? You should be able to say, when somebody signs up on your website or, enters a customer chatbot, you can say, I would like to return an item. And it can say, okay, I see these are the 3 items that you bought previously. Which one would you like to return? Instead of saying, can you please enter your order ID, can you please enter information about yourself, can you, and put your email address. Yes, you need to authenticate them, but once you have authenticated them, you should be able to recall information about them directly. That is what long term memory serves. So long term memory and short term memory, we have seen, is what empowers agents to go to the next level. And we have seen that when you have memory attached to LLMs or agents, they outperform by leaps and bounds. If you want to do personalization, long-term memory serves a great process. If you want to build something, as you building whatever use case you have, in those use cases, having these kinds of memories, and some of you might ask, what the hell does memory means? Memory could just be a JSON file, which is where you're appending all the different conversations. It could be as simple as that, or it could be something which is very, 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 very extensive. So you could have knowledge graphs. So a company that sort of does a really good job in building memory. There are other companies also, but this is the company Mem0. It does not build you an agent. All it does is it remembers the kind of request or the information that you're passing along. So when you say, I prefer aisle seats when flying, but for long flights, make it a window seat. And when it says, can you book my flight to Berlin? It's a long flight. It will basically remember the fact that, hey, for long flights, you prefer a window seat. So, and it will book your flight, which is relevant to your request. So memory addition to LLMs or agents plays a huge role that brings all the things together for you when you're creating a customer user experience. The customer experience really relies on your capability to remember about your customer, which is not PII data. I'm not saying it should remember your credit card. I'm not saying it should remember everything about you, your date of birth. There's some PII data which should not remember. But overall, you know how ChatGPT didn't used to remember anything about you, and now it says memory updated. This is what that memory is. So when you write a prompt and you say, can you please write about my company, write a overview about my company, and it remembers everything that happened behind the scenes, that is what we call memory. So memory plays a huge role. Um, um, Memory plays a huge role in how we are building this, how we are building agents. A lot of customer facing agents have memory now. We are working with a ton of companies where we are building memory based agents for them, because they reduce the time on customer onboarding. They remember who you are, and they have a given way of solving the problems. In short-term memory, we use short-term memory, remember, to basically go from step to step. So each steps that you follow over here, there is context which is generated. We store that context so that we can say, hey, this is what has happened so far. How would you like to proceed for the next step? That's where sort of you're adding statefulness to your agents, and you're giving them the capability to answer. And there is a huge space within a memory of agents. Basically, when you have episodic memory, you have procedural memory, you have semantic memory. Don't worry about right now what it is. There are many different forms, but again, I think if you should take a screenshot of this one too. What this explains is, there's episodic memory, semantic memory, procedural memory, that sort of builds you better tools which are out there. They all are built for specific use cases. Now, they could all be one database. I'm not saying that they need to be separate databases. I'm saying that each memory or database within this is built for a separate use case, and they're used within the prompts that you build to build better context engineering. So some of you might have heard of prompt engineering. From prompt engineering, we have context engineering. This is how we design our agents to be better, which is through context engineering that enables us to sort of follow through our product and build something which is much more powerful than basic LLM behind the scenes. Short term focuses on immediate, holds info needed for current decisions. It is non persistent, doesn't carry info across all tasks or tool calls, pulls relevant data from long term memory and external sources to support real time. So just remember, it is non persistent, which just means that once we have used the whole tool, everything it sort of dies. But short term memory, it's important to remember what you are, who you are, like what are the different steps and processes that are needed to build when we're going from one tool to the other. Long-term memory basically stores previously discussed information. For example, stores how to do things. Muscle memory for one of them is procedural, which serves as a muscle memory. Semantic is, so I'll give you a simple example. We build customer support agents that basically a user can log in, they can return an item, they can search for an item, they can ask for an item, they can update their address, all to an agent, like an AI agent. They can speak to it. So the way we use them is basically we try to use a combination of these memories to remember about it. So let's say a person is trying to apply a coupon that they've already applied. It's very difficult to store all that information. So we use memory that sort of says, hey, you used a coupon less than 30 days ago, you're going to apply the same coupon, or a similar thing cannot be applied. So in order to enforce and sort of help with also guardrailing and protect how your LLMs work or your agents work, long-term memory serves a great purpose. There's a lot of write-up on this. Tomorrow, as we'll go through different agents, we'll show you some form of memory so you can sort of evaluate how does memory work behind the scenes. There's, again, as I said, there's a lot of reading material. We are working on a document that you can sort of follow through for all the reading material, but there is definitely a lot of work reading material. If you follow my Substack, we have a ton of articles over there that you can sort of read through. I've pasted all of them in the on the YouTube channel. However, if you just follow us or follow me on Substack, my Substack has all the articles, all the information you want to learn. So the first one is agents are here, they're staying. Some of you might have seen this already. This is an important one, which is how agents think. Again, this is free, guys. I can't do more than making things free. All I want you guys is to just follow along, ask questions, learn about how these things are built, so that you know what is being done and how they're built. Right. So this one follows, how agents think, and the third link that is over here is memory, which is the agent's brain. This is how it shows how agents, how does memory work over here, and why is it important? What role does it play? What are some of the implementations of it? So I want to make sure that you guys have the time to go through them. And all you need to do is just sign up. If you have not signed up on Substack, sign up on Substack and follow through this. These are great examples for you. Even if you don't want to follow them, just bookmark it for yourself. This way, at least you have this information available to you, so that you can use this. All right. Okay. So what I'll do is go back here. All right. So tomorrow we would love for you to join us to talk about Google Agent A2A, Agent to Agent, and ADK MCP. We'll go in detail about talking about those things. ADK sort of or A2A protocol allows multiple agents to talk to each other, delegate tasks, coordinate with each other. You will also have the opportunity to learn about MCP, and then you can see how the ADK connects and pieces it all together. With that, really want to thank you all for the opportunity to join here. Remember, um, I would love for you all to sort of post about this, um, and if you want to be considered for the scholarship for this course or for what I teach on different platforms, what I would say is if you go here and you you scan this QR code, post a link about what we do, share one key takeaway, submit this form so that when you submit this form, we can give you the, we want to give you the opportunity to enroll in our live courses, which we teach on Maven or other places. I really want to democratize the availability of data, availability of AI. As we know, there's a lot of FOMO out there on what we don't know. I think what I'm trying to do is I'm trying to make it available for everyone so that you guys can learn these things better from what you know and improve over time yourself. There's no shortcut, but at least I can show you a direction. I can show you how it's built, on how they're built, so that you can learn and use them in everyday life. All right. So with that, we will end our session. Again, thank you everyone for joining in. This is a great session with you all. If What I want to do is I want to use the last 5 minutes to answer as many questions as I can. Hassan, if you want, I'll add you here. If you want to help, can you help me with the questions if there are any?
Yeah, Hamza. So our first question is there a way to be surgical in terms of assigning weightage? I'm using it in an abstract way to the use of working memory versus long-term memory.
Yeah. So they are very, very different applications. So you don't need to assign weightage. Short-term memory, you don't control in any way. You don't do anything with short-term memory. You implement short-term memory to run within your workflow. You use long-term memory to improve the capability of the agent that you have built. So there are two different things. I just want to identify them. They don't work hand in hand, they work separately, but collectively they make your agent bring to life. So use long-term agents when you have something that is not happening within the session. Use short-term when everything is happening within the session. All right. Next question.
Yeah. How do we ensure transparency in terms of the type of memory used?
So I think that's a great question. You can do grounding, right? You can use the grounding that is created. So again, it all comes back to evaluation. Am I able to evaluate correctly that this is the actual information? And remember, when you have too many LLMs in the middle, you're bound to hallucinate. You're bound to make mistakes. But most importantly, build a simple MVP, run with different examples, and at the end of the day, when you see those examples, evaluate the performance on them to know that you have gotten the right responses. It's the same thing we do with RAG. Whenever you run RAG, you have to have evaluation of some sorts, which enables you to understand what's happening. All right.
Thanks. Okay, so this is a question regarding scholarship. Apart from scholarship, is there any chance for us to join your team or to become your TA?
You can always apply for a job with us. You can always reach out to us, and if we're always hiring. So reach out to us, reach out to our team, email us. LinkedIn would be great. Anything. We're always hiring.
Okay, thank you, Amzad. I think that's it. We
All right.
don't have other questions.
All right. Thank you, everyone. Thank you so much for your time today. Remember that we'll all see you tomorrow for our last session. It's been a great crowd. Thank you, everyone, and we'll see you tomorrow.